Welcome back, dear students. In this video, we are going to look at binary arithmetics, and we are going to focus mostly on binary system, although the concept we shall use here is applicable to the other system, that is decimal, hexadecimal, and octal. In computers, numbers are represented in binary form. The arithmetic operations performed by a computer therefore involve binary numbers. The next few sections describe how binary arithmetic operation like binary addition, subtraction, multiplication, and division, though we shall focus only on the first two. The addition in binary is similar to that in decimal system we learned since the primary school. Remember, if the sum is less than 2, then it's the result we obtain. But if the sum is above or equal to 2, we divide the result by 2, the result is carried and the remainder maintained as answer. As example, if our sum gives us 3, we know that 3 divided by 2 is equal to 1 remainder 1. So we have 1, that is the remainder is the answer we have, and as answer, and we carry 1. If our sum gives us 2, 2 divided by 2 gives us 1, remainder 2 divided by 2, so it gives us 1 remainder 0. So we have 0 as answer and a carry of 1. Now let us look at these two examples. Perform the following operations: 1111 plus 1110 base 2 and 1101 plus 101 base 2. So this is the first one we have. You know that we are filling always starting from the unit. That's what we have. So a student saying 110 is wrong because we must make sure that we are filling unit, tens, hundred, and so on. So now 1 plus 0 is 1. So there's no problem with that. 1 plus 1 gives us 2, and 2 is already equal to the base, and we know that in a particular base system we cannot have a digit equal to that base. So when we take 2 divided by 2, it gives us 1 remainder 0. So I will hide the 0 and I carry 1, as you can see. Now for the next one, I'm going to have 1 plus 1 plus 1. So what do we have? 1 plus 1 plus 1 gives us 3, and 3 divided by 2 is 1 remainder 1. So I hide the remainder, which is 1, and I carry the other one. So now the next operation is 1 plus 1, which gives us 2, and 2 divided by 2 is 1 remainder 0. So I carry the 1. And now for the next operation, now it is 1 plus nothing, which gives us 1 plus 0, which is 1. That is what we have. So 1111 plus 110 gives us 10101 base 2. For the second example, we have 1101 plus 100. So here is supposed to be 100. So take this as an example, dear students. So let us look at this. 1 plus 0 gives us 1. 0 plus 0 gives us 0. 1 plus 1 is 2. 2 divided by 2 is 0 remainder 1. So there I still have 1 plus 1, which is 2. So 0 remainder 1. Then I have the 1. So our answer is 1101 plus 100 base 2 gives us 10001 base 2. So I'm waiting for the answer to this question in the comment section, dear students. Now, subtraction. The most important rule when it comes to binary subtraction is that when an operation is not possible and we borrow from the adjacent bit, we are actually borrowing the base, which is 2 in case of binary subtraction. So just take note. In case, for example, here you are performing octal addition, you need to know that what if the sum is greater than or equals to 8, then you have to divide and put the remainder as answer, and you carry the quotient of the division. But here we are on binary. So these are the three operations we are going to use to properly explain to you how borrowing is done in subtraction. So for the first one, we have 1101 minus 101. When you take 1 minus 1, it gives you 0. 0 minus 0, 0. 1 minus 1, 1 and 0, sorry. 1 minus 0, 1. So that is our answer. For the B part, I have 1101 minus 1010. 1 minus 0, 1. 0 minus 1 is not possible, as you can see. So what do? We borrow 1 from this 1. So we borrow 1. So as I borrow 1 here, because this is 1, if I borrow this 1, I am left with 0. And actually, what am I borrowing? It is the base I am borrowing. So what I'm adding here is 2. So now, as I borrow 1, you need to understand. If I borrow 1 from 1, I will be left with 0. And what I have borrowed to add here is actually the base, which is 2. So now 2 minus 1 gives us 1. 0 minus 0 gives us 0. And 1 minus 1 gives us 0. So 1, 1, 0, 1 minus 1, 0, 1, 0 is 1, 1 base 2. Remember that when it comes to integers only, if the first digit are 0, 0, they can be omitted. But somebody saying that the answer is 0, 0, 1, 1 is still perfectly correct. For the third question, we have 1, 0, 0, 1, 1 minus 1, 1, 0, 1. And we know that what? 1 minus 1, 0. 1 minus 0, 1. 0 minus 1 is not possible. I cannot borrow from 0 again. So this man, we need to borrow from this man first before borrowing to this one. So when I cancel this one and I add here, I am actually adding the base, which is 2. Then I borrow from this 2 to add to this man. Remember, when I borrow 1 here, I'm left with 0. What I added here is the base. So now I borrow from this base now, which is 2, to add here, which is still the base. Because take note, when you are borrowing, it is binary. What you are borrowing is actually the base. So when I cancel here, I will be left with what? With 1. And that's why I added here, it became the base, which is 2. Let me take it all over. I borrow 1, I'm left with 0. What I added to this 0 is 2. So because we are in base 2. Now I borrow 1 from this 2. When I borrow 1 from 2, I'm left with 1. What I added here is the base. 2 minus 1 is 1. 1 minus 0 is 0. And here we have 0. So 1, 0, 0, 1, 1 minus 1, 1, 0, 1 is equals to 1, 1, 0, because these two 0 can be omitted. So that is what we have. Now, I hope as you saw this, you won't have any problem if you are giving addition or subtraction when it comes to other bases. And also, when it comes to multiplication and division, I will advise the conversion to decimal, perform the operation and then convert the answer. Though it is still possible to perform binary division and binary multiplication normally without necessarily converting, it is still possible. Though it rarely comes, because remember this video is with respect to Advanced Level Computer Science 795 and Advanced Level ICT 796. If a student really wants to know the division and multiplication of binary numbers, comment about it and I will make a video for that. So do not forget to like, to subscribe and to share, because we have concluded another important part of this chapter, which is binary arithmetic. In the next video, we are going to look at the way negative numbers are being represented in the computer, the different notation used. Do not forget to like, to subscribe and to share, and see you in the next video.